Hello guys, welcome to a new video. Today we are going to solve this simple circuit. Okay, we are going to calculate uh, all of the currents across the resistors by means of Kirchhoff voltage law. Okay, so uh, remember that the first thing I have to do when I am solving these type of circuits, in this case by using Kirchhoff voltage law. Kirchhoff voltage law states that the voltages across a mesh equals zero. In this case, I have to draw a current. Look at the mesh on the left. I drew I1, and let's use another color to draw the current around the second mesh. I can draw these currents in any direction I want. But once I draw these currents, I have to mark the voltages across the resistors due to this current. In the case of I2, look that the way I drew this current causes a voltage with the polarity you are watching in 1 ohm resistor and in the 3 ohm resistor on the right mesh. The way I drew I1 causes the voltage with the polarity of the 5 ohm resistor you see and the polarity of the 1 ohm resistor in white that you are seeing. I'm going once I draw these currents, okay, and I draw the polarity of the voltages across the elements of the circuit, in this case, or the resistors, caused by the way I drew the current, I am going to go around the mesh to comply with the Kirchhoff law, with the Kirchhoff voltage law, which, as I said before, states that the algebraic sum of the voltages across a mesh equals zero. In this case, on the left mesh, I departed from the lower point of the mesh, as you can see, marked with an X, okay? And I'm going to go around mesh 1 clockwise, okay? So if I go around this mesh clockwise and I depart from this point, the first voltage that I find is the voltage due to the 5-volt voltage source. And as I'm going from minus to plus, in the way I am going around the mesh, I see that this is a voltage rise. So I'm going to take into account voltage rises as positive and voltage drops as negative. So once I go through the 5-volt voltage source, I find a voltage drop across 5 ohm resistor. I find a voltage drop because as I am going uh, clockwise, the first sign that I find across the resistor is a positive sign, and when I continue going around the mesh, I find a negative polarity. So this is a voltage drop across 5 ohm resistor, so I write it as negative. So I write minus 5 times I1. I continue by going through resistor 1. I can see that when I go clockwise on the left mesh through the 1 ohm resistor, I find a voltage drop due to I1. Look at the polarity of the white signs are marked across the resistor. So there is a voltage drop due to I1, so I write minus 1 times I1. And going this way, I find that I have a voltage uh, rise, in the previous case was a voltage drop, I find a voltage rise due to current I2 because I'm going the way I'm going around the mesh, the left mesh, I'm going from the negative blue mark to the positive blue mark. So I find a voltage rise. So I write it as positive plus 1 times I2. And finally, I see that there is a 1 volt voltage source. So I'm going from the positive terminal to the negative terminal. So there is a voltage drop. I write it as negative. Okay. So this algebraic addition of these voltages equals 0. So by solving this equation, okay, I get that 6 times I1 minus I2 equals 4. So doing the same with the right mesh and departing from the ground node on the lower right, you can see, or on the lower center, as you can see, I'm going to go around the mesh clockwise as well. So when I do this, the first thing I find is a voltage rise due to the 1 volt voltage source because I'm going from negative terminal to positive terminal. I'm writing the equation for mesh 2, okay? So I find this voltage rise, so I write it as positive. I have plus 1. Then I'm going to go across 1 ohm resistor. So in the 1 ohm resistor, I'm going clockwise around mesh 2. I find a voltage rise due to I1. Look at the white marks across resistor 1. I'm going from minus to plus. It means there is a voltage rise due to I1. So I write in the equation plus 1 times I1. And due to I2, I find the blue marks, okay, which I'm going from positive 1 to negative 1. It means there is a voltage drop due to I2. So I write in the equation for mesh 2, I write minus 1 times I2. Then I'm on the upper point in the center and I'm going clockwise through 2 volt voltage source. I find a voltage rise whose value is 2 volt, so it is positive, all right, plus 2. And finally, due to I2 and the way I'm going around the mesh, I find a voltage drop across resistor, the 3 ohm resistor. So as it is a voltage drop, I write it as negative, minus 3 times I2. And the addition of all of these voltages due to Kirchhoff voltage law must be equal to 0. So by solving mesh 2, I find the second equation, I1 minus 4 times I2 equals minus 3. So by solving this equation system, I get that I1 equals 0.826 amperes. But I1 is the current that is going through 5 volt voltage source is the same as you can see on the left mesh. I1 is the current that is going through 5 volt voltage source and is the current that is going through 5 ohm resistor. So this is the current through 5 ohm resistor. Then by substituting this value in any of the equations, I can get that the current uh, around mesh 2 equals 0.957 amperes or 957 milliamperes. I2, if you look on the right mesh, I2 is the current that is going through, look in the upper side of the mesh, I2 is the current that is going through the 2 volt voltage source, and I2 is the current that is going through 3 ohm resistor. So This is the resulting current from 3 ohm resistor, as you can see in the results, okay, equals I2. But the current going through the 1 ohm resistor is the resulting current I1 minus I2 if we define it that way as we did here, or you could define it as I1 minus I2. In this case, I defined the current through the 1 ohm resistor as I2 minus and I1, and if it turns out to be positive, it means that the current across 1 ohm resistor is going the way I2 goes. It means it is going upwards, as is the case in this calculation. I get that the current I2 minus I1 equals 0.131 ampere positive. It means that it goes uh, upwards. If I define, if I had defined I the current through 1 ohm resistor the way I defined it, but it turns out to be negative, it means that this is going in the opposite way. It will be flowing through 1 ohm resistor going downwards. Okay, so it depends on the convention you use when you define the resulting current. In this case, as I defined it as I2 minus I1, I suppose that the resulting current is going the way I2 does. Okay, if it turns out to be positive, as it was the case, it means that it goes the way I2 goes. It means that it's going upwards. Okay, so it depends on the uh, convention. Okay, so remind that the first things that we have to do is to draw the corresponding currents in all of the meshes, and I have to draw the corresponding voltage drops caused by those currents through the elements of the circuit, of the mesh. Okay, once I do this, I can go around the mesh the way I want. I can go clockwise or I can go counterclockwise, depending on the way I decide to go. Uh, I'm going to find different signs in the equations, but at the end, it is going to be the same. Okay, so it doesn't depend the way I go around the mesh. I'm going to get the same results. So now let's see the simulation of this circuit by means of the use of LTSpice. I'm going to set simulation time. Okay, and the first I'm going to get is the current across 5 ohm resistor as you are looking from left to right. It means it yielded positive. It means that it is going from left to right and is the same current I calculated during the analysis of the circuit. Okay, so the same way we are going to get the current through the 3 ohm resistor this way from the upper side to the lower side. Okay, so I can get that the current is the same I got, and I'm going to simulate the current through the 1 ohm resistor. In this case, I'm going to simulate it from the upper side to the lower side, and I can see in the drawing that it results negative, so it means it goes in the opposite way. So if you like it, please thumbs up. and I invite you to subscribe to my channel.